Hello, thanks for joining my barcode training session. I hope you find it useful. Hopefully it'll teach you a bit about barcodes, reading technology and things to be aware of. Barcodes nowadays are appearing on all sorts of different things, maybe not quite so strange as these ones, but it's surprising where barcodes are now being used, and the demands put on readers are becoming more significant. First thing we need to do is to know how to identify what barcode is what type. You notice these here have quite distinctive start and stop sequences. That helps us identify the main barcode types. And these three main types, code interleaved 205, 39 and 128, will cover most industrial applications, and occasionally when you're dealing with packaging and so on you might find EAN or UPC codes which look like these. Very simple start and stop patterns. More details available on the app for Android, on Code Calc, or on the website, on Weebly website. So for interleaved 205, you notice here the easiest way to identify it is a thin bar, thin space, thin bar, then thick bar, thin space, thin bar to finish. Looks very similar to code 39, but key difference is the big space between the first bars. Code 128 is quite different. It has much fatter bar at the end, and it has multiple bar widths throughout it. And EAN 13 has thin bar, thin space, thin bar, and likewise the same to finish. There's a few more slides that you might be able to pause on if you want to look in more detail and read the information about the different code types. So once again, code 39, notice the large space and a sample of the real code. Code 128, samples of the two codes. There are different tables in code 128. You can see here we've got code 128 table A, B and C. Details are up here, you can read them, but in essence table C allows you to print numeric information in double density. So this code here on the bottom right is printed in standard density, and this is the same code content printed using table C, double density. You can see how it saves space, which would either allow a lower cost label, or if the barcode could be increased, it would allow a larger module width, which means we could use a lower cost barcode reader. Once again, EAN, easily spotted by the thin bar, thin space, thin bar to begin and end. Also the dropped bars, sometimes in the middle, but generally at the ends, and the numerical information in between. You might want to skip this if you don't really want to know how a barcode works, but if you remember your binary from school days, where you use binary 1248, if we use a 1247 code, it means using any two positions, we can count up to 9, or 0 through to 9. So for example, 1 add 2 would give us 3, 1 add 4 would give us 5, 1 add 7 would give us 8, 2 add 7 give us 9, and so on. If we add 4 and 7 it would give us naturally 11, but we class that as a 0. So all you need to do is decode the first set of bars. So we ignore the start and stop sequence. Those don't contain any data. The contents inside here is what carries the data. So first we look at the first set of 5 bars. So bar 1 is a thick one, so we consider that one to be valid. We ignore bar 2 and 4 and 7, and P is like a store. So that means the first digit of this barcode is 1. Then we look at the next 5 spaces, starting from here. So the space at position 1 we ignore, but in 2 we consider, and the store is in this position here. Then we look at the next 5 bars. So here you can see the next 5 bars starts with a 1 and a 2. Obviously add up to 3, hence the barcode is 1, 2, 3, 4. Sorry about the unoriginal barcode. Anyway, try this one yourself. Maybe hide the result first and just see if you can work it out. Here are a few critical success factors when dealing with barcodes. The barcode vital signs, so to speak. Quiet zones infringed. This is very important. The scanner needs to see a quiet zone, so printing or logos either side of the barcode will stop it from working. Poor contrast. Goes without saying, if you can hardly see the code, it's not going to read. This is called a low aspect ratio. You can see the bar height is much too small. compared to the bar length. Often if you're printing codes, the pixels in a thermal transfer printer might burn out, and that'll leave a white line down the codes. Beg your pardon. A white line down the barcodes. Obviously these ones, if you get multiple pixels side by side, these lines could become as big as a bar, and then it no longer is just a little white stripe, it is actually a white bar, and that will stop the barcode from reading. You can see here that the narrow bars are not the same size as the narrow space, and they must be. That's very important. The most common problem is people don't use a 10 to 15 degree angle on the code. They mount the scanner looking perpendicular to the code rather than at this 15-degree angle. And one thing to remember is that a lot of systems actually need a quiet zone all the way around the code, not just at the beginning and at the end. If you're reading a code omnidirectionally, it needs a quiet zone along the top and also along the bottom. Here's a few sample codes, a few rogue barcodes. So this isn't the fault, that wouldn't really be a big problem. But here you can see the quiet zone has been totally obstructed by the label starting to peel up. Once again here, another problem with the quiet zone. Quiet zone is supposed to be 10 times the last bar, and clearly that one isn't. This code here was a problem only in as much as if you look and try and identify the code type, you'll notice it's a most unusual code. It's actually code a bar. You see it finishes with a thick bar and starts with a thin one. And the customer actually thought that he was printing a code 128. So have a look at this slide here. You might want to pause the presentation and just see how many faults you can see. So if you pause it now, and then when you've counted up the faults, we'll go through and identify each fault. Okay, so the first fault on this code here, no quiet zone, and obviously this bar here is missing. So that one won't decode. Once again here, that quiet zone there is not 10 times this bar width. Also, the human readable has been truncated. So if the scanner broke, nobody can even type this in manually. Here you can see the barcode is actually printed over a stripe. So part of the barcode is actually printed in here, which is no good, it won't read. And there's no quiet zone. And you can see the tear strip down here where the barcode is supposed to be torn out. The barcode is actually printed part way over that, so when they tear it out, a big lump of the barcode will be missing. There's also a lot of show through. You can see marks through here where there's white spots, and obviously a scan line scanning through this part, for example, would read that bar there as a thin bar. Once again, quiet zone is too small. That quiet zone there is not 10 times that bar width, and the code is printed over the tear zone. I don't know if you can make out that small line there, but that's where the barcode is supposed to be torn out. And you see all the show through once again. It's a poor quality code. Another one here, you can see that the human readable numbers have been put along the barcode which are obstructing the quiet zone. Likewise, we've got a lot of show through on this code. Okay, that's it for that one sheet. I hope you got a fair number of those problems. This one here is showing a low contrast code. You can see it's very low contrast code down here, but the quiet zone on here, it's not really very well defined. There's a lot of skip. This barcode could not be read by a laser scanner. This could only be read by a vision system, or for example the Lector or the ICR 620 or ICR 840 range of scanners. And also you can see down here there's a hole drilled in the area where the quiet zone should be. Once again, this one here, hopefully you notice the quiet zone is missing there. Otherwise this part of the code is fine. Very dark contrast, probably because the heat has been turned up on a thermal transfer. But when we go to the code here, which we call the ladder code, we'd call that one the picket fence and that the ladder in this orientation, you notice this particular code here, unfortunately the white space that should be there has now been totally obstructed by the dark bar. And that's because the heat is on too high. It's bleeding out, it's called bleed. So the ink has bled, or it's put far too much ink down, so the thick bar is thicker, the narrow bar is smaller, so it's totally destroyed. Once again here, same problem. You can see those spaces there, that space is supposed to be the same size as that bar. Clearly this isn't going to work. And once they solve that problem, there's still an issue, because you can see all of these issues within the code where parts of the bars are actually missing or the wrong width. Incidentally, that star there Does anyone recognise the code type? Do you remember the stop sequence, thick bar, thin space, thin bar? And the crucial difference here, where you've got a thicker space between the first bar and the next bar. Yep, hopefully you got that right. It's code 39. And you notice code 39 is often represented as showing an asterisk either side of the code. And that's because the code sequence, which is the first 9 bars and spaces, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, up to this point here. If you look for that pattern, you'll see exactly the same pattern down at this end of the code here. And the first 9 bars and spaces is an asterisk, and so too is the finish with code 39. Some people print that asterisk, and some people even want it transmitted out to their host. Once again here you can see that the narrow spaces are far too small and there's damage within the code, various points of damage where the code isn't correct. Okay, so just a word of warning, I'd like you to read through this, I shan't read it verbatim, but unfortunately if you let bad codes go out to your customer, or if you let your customer print bad codes, he probably has a customer or someone else who wants to read it further down the line, and that's going to cause immense problems for them. Often there are fines imposed, and quite severe fines, for badly printed codes. So it's important to advise your customer, or at least query with him, if it's sensible for his business to let poor quality codes leave the door. One of the problems you've got is that our scanners will read really bad codes if we set them up correctly. And a lot of people do really need and want that. But it's best practice for us to explain the reasons to our customers. And we have to remember that SICK make very good scanners. Our competitors don't all do the same. A lot of our competitors will struggle to read these. So we might read it and send it out, and later in the distribution chain, our competitors can't even read it. And that causes a big problem. This next section is things you might like to know about barcodes. This will be on a separate video.